So we can think, again, so by converting to spherical coordinates, we can, instead of thinking of the wave function as composing of terms of x, y, z coordinates, we can convert it instead into having terms of r, theta, and phi. Okay? And we're not going to get into how we actually change the Hamiltonian or the wave function for that, but what we end up with is when we solve for the three-dimensional particle in the box, what we get is that our components can be separated, mathematically separated. Okay? And so what that means is that we get a component based on the term r, a function which we call big R, which is dependent on the radius r. We get a second component that's multiplied by this, which is big theta, which is dependent on the term theta, again, from spherical coordinates. And then, again, multiplied by all this is a function phi that is dependent on the angle phi from spherical coordinates, okay? And so we can mathematically separate this, and so we can think, think about different components separately of the wave function, which will help us conceptually understand the system a little bit better. In fact, what we end up doing is we take out what is the radial, which is dependent on the radius, okay, and we combine these two terms, these two functions, right, into a singular function which we call big Y, which is dependent on both theta and phi, okay? And so we call this the radial function. And we call this the angular function. And together, these two functions multiplied together using the terms r, theta, and phi, we can describe the wave function that is the probability of the electron. We can describe the wave function, rather. Let me back up. We can describe the wave function in terms of these two components, and that tells us about information about the electron within the wave function. And if we square, right, the wave function as we've discussed before, right, that can give us information of the probability of finding the electron at the spherical coordinates r, theta, phi. And so what we're going to do next in the next couple of videos is we're going to look at the behavior of the radial function individually from the angular function to get a better idea of how we can describe these three-dimensional wave functions.